Hi, in today's video we will cover another classification algorithm, that is decision tree. In today's session we are going to cover how to build a decision tree, how to search within a decision tree, and how to calculate an entropy for a decision tree. In our next video we will cover algorithm, prune, decision tree, and strength, weaknesses and application of decision tree. So let us start with our very first topic of decision tree. Decision tree is basically one of the widely adopted algorithm for classification. From a name it suggests that it builds model of machine learning for classification in tree structure, and it is basically used for multi-dimensional analysis having multiple destination classes. It is having very fast execution time and very easy to interpret the rules of given training data. Basically, decision tree builds a model which predicts the value of output variable based upon input variable which is given in feature vector, and every node in decision tree corresponds to one feature vector. Here in this particular diagram, as you can see, these blue nodes are called as internal nodes of test attribute. Now there are three different types of node. One is called as branch node, root node and leaf node. So internal node is a node which tests an attribute. Some attribute is tested and outcome of that attribute can be either false or true. And each branch in a particular decision tree is corresponding to one value or an output of an attribute. In this example, we have covered two output of each attribute, that is true and false. Leaf node in a decision tree assigns a classification label. Okay, so classification label is assigned with these orange circles. This can be, say for example, class 1, this can be class 2, again this can be class 1 and this can be class 3 also. So it depends how many class labels or different classes are there in training data. Now in this particular diagram, these blue node is called as root node and another two different blue nodes are called as branch node. An example of decision tree is that, let us consider we want to find out whether a person is fit or not. So according to our training, more precisely labeled to training data, we have found out that age of a person can be either less than 30 or greater than 30. So any person who is having age lesser than 30, then we have to evaluate another attribute value, that is whether a person eats lots of pizza or not. So if answer of another attribute is also yes, then we can conclude that person is having label of unfit. If age is lesser than 30, that means output of this attribute is yes and another attribute's value is no, that is doesn't eat lots of pizza, then we might say that person is fit. Coming over this another branch, what is the possible value of attribute age less than 30? So other than yes, person can have value no under this age less than 30 attribute. So age less than 30 is the name of attribute. In that, if we have value no for a particular person, we have to look into another attribute's value. The another attribute is exercising in the morning. Whether that person exercise in morning. Within the attribute, we can have two different values, yes and no. If person exercises in doing an exercise in the morning, we can conclude that we have to assign a label of fit to that person. And if output or value is no under this attribute category, then we can assign a label of unfit. So as you can see, this is a binary classifier. We have only two different set of classes, that is C1 and C2. And each attribute is again of binary type. Yes or no output is there for each of these attributes. Let us move ahead how to build a decision tree. decision tree which corresponds to given training data is built. So that means there is no as such a global decision tree. For a given training data, we have one decision tree, and it follows an approach that is called as recursive partitioning. Recursive partitioning approach splits data into multiple subsets on the basis of feature value. Now remember, a feature is nothing but an attribute which contributes in predicting some value or predicting a class of particular data. So an attribute which contributes to some information in prediction is called as feature. If attribute has only true value, true and false, or it might happen an attribute can have multiple values. Say for example, if we have three different values, we can have subset of data in three different categories. If an attribute can have only binary value, true and false, we will have set of subset of data, or those data which is having true value and that set of data which is having false value. So that is what we call partitioning is. But this partitioning is recursively done. That means in this particular data set, again I will set some another attribute. If that attribute is again dividing data into two different parts, this complete partition is again partitioned into two different subsets. Likewise, here also we have another attribute which partitions data into three different subsets. Then again, this subset is partitioned again into three different categories. So that process is called as recursive partitioning. Procedure of partitioning starts with root node. We are considering entire data set as our root node. Now over this complete data set, we will find out a feature or a particular attribute which predicts a target class in strongest way. Okay, now how to find out which attribute is strongest or contributing maximum to find out the target class. That can be done with two things. One is called as an entropy, and with an entropy we calculate something called as information gain. And using that selected feature, we make multiple partitions. These partition can be two if attribute or feature is binary, and if attribute or feature is having more than two value, we can have multiple partitions accordingly. Now, next point says that data in each partition is having distinct value for a feature which is selected for partitioning. Say for example, I have selected one attribute. This is my complete data set. Okay, and in this data set, this is an attribute, say this is attribute number 4, which is strongest contributing attribute, for example. Now, this attribute is having only two values, either it can be true and it can be false. So, in our first subset, we will have two partitions, subset 1 and subset 2. Subset 1 will have all those data elements for which attribute 4 value is true, and subset 2 will have all those data elements for which attribute 4 value is false. So as you can see, in each partition which is having distinct value for a feature which is selected for partitioning. So, and likewise we continue splitting our data set, which is actually now subset, into nodes on the basis of feature which helps in partitioning. Later on, if this subset is considered, we will select an attribute which strongly divides or which strongly contributes in predicting the value of class label. That again can be calculated with the help of entropy and information gain. And we will continue this process of dividing our data or subset into partitions unless and until some stopping criteria is reached. Now we have to discuss this stopping criteria. Not every time we have to stop when we cannot more calculate two different partition or more partitions. So there are three different stopping criteria. Anything can be used as per the requirement of a problem. First criteria says that all or most of the examples at a particular node is having same class. Okay, so when we have a particular set in which all output is belonging to same class, there is no meaning of making partition because we know that output is same for this subset. Okay, so whenever for any partition, if output variable is having same value, we cannot further divide that partition into more than one partition. Second is that when all features have been used in partitioning. Say for example, we have only 5 features, A1 to A5. And for example, first feature we have used is A4, then we have used A2, we have used A1, A3 and later on A5. Now we do not have any more feature on the basis of which I can partition my data into some subset. So in that case also we have to stop growing our tree, and that is called as stopping criteria of a decision tree. And the third criteria is that when tree has grown to its predefined threshold. In total we have 3 different stopping criteria of a decision tree. Now let us see how to build a decision tree for a given data. So first let us understand data in order to build a decision tree. This is a data set given for a particular company over which some students are getting hired. So a company is hiring a student based upon their skills of CGPA, their communication, their aptitude and their programming skill. On the basis of values of these 4 attributes, they have past history whether they have offered job to that particular student or not. So output of job offered can be either yes or no. Again, it is a binary classification. A CGPA of a student can be either high, medium or low. So possible 3 values of CGPA. Communication of a student can be categorized into good or bad. An aptitude of a student can be high or low, only 2 categories is there. And programming skill of a person or a student can be good, bad. Here we have given training data and question is asked that if there is a student with the name Chandra which is having very bad communication skill, that is communication is bad, but aptitude is high, that is good aptitude, and programming skill is also bad, will that Chandra get a job in a company? So this company's data is given, and according to the past history of this company, we have to train our machine. That is nothing but we have to make a decision tree. If I want to answer, let us consider this is the final decision tree and I have to go with Chandra, then what we can do is that we can use one of the 3 solution or searching approach. Very first searching approach is exhaustive approach. Place an item in a first group of class and recursively examine that group of class. Say for example, we assume Chandra will get not placed. That is class C1. So this is my class C1 and job is not offered, again class C1. Now look into C1. What are the values? We have aptitude low. Is Chandra is having aptitude low? No. So Chandra is not fitting in this class at this branch. Look at this here. When sorry, this is class 1 only. Okay, I have made mistake in writing. This is also class 1 and let us put Chandra in this class. That is job is not offered. Let us look into this that CGPA is low. Is CGPA is low? Now let us see how entropy is calculated, which is used for making a decision tree. So for any training set which is denoted by S, entropy of that training set, entropy of S is measuring the impurity of S or information contained in S, and the entropy formula is summation from 1 to C minus P of I into log of Pi to the base 2. Say for example, this is my given data. What is an entropy of a complete data set? So I have to look into an output variable. For an output, we have only 2 outcomes. One is yes and another one is no. So we have to count out the entropy of a complete data set. So count is given that yes samples are 8 and no samples are 10. That is in total 18 samples are there. Now, to calculate entropy, we have to calculate P of I. P of I is nothing but 8 by 18 for this particular cell, and for no, it will be 10 by 18. So these values are turning out to be 0.44 and 0.56. And P of I into log of P of I to the base 2, that can be calculated for this value. So 0.44 into log of 0.44 to the base 2 is 0.52, and 0.56 into log of 0.56 to the base 2 is 0.47, and summation of these two values is 0.99. Now, in the next step, we will calculate information gain. So, information gain is created or calculated on the basis of decreased entropy. Now, entropy will decrease after we split data. That is, original data contains in total 18 samples. If I bifurcate and make two different partitions or three more than two partitions, if any entropy is lost, that is called as information gain. So information gain for a training set is based upon an attribute using which you have created partition is A. So information gain of S comma A is entropy of SBS minus entropy of SAS. Now what is SBS? SBS is nothing but entropy before partitioning, that is entropy of original data set. And after partitioning, what is an entropy of all these training data set? Entropy of this set and this set. That entropy is called as entropy after splitting. And after entropy split is calculated with entropy of this partition and this partition, which is getting added with weights. Now, how to calculate weight of each partition and later on add all these entropy along with weight to generate final entropy, and the difference between original before splitting entropy and after splitting entropy is nothing but our information gain. Before splitting, that is S of BS, before splitting, the entropy of complete data set was 0.99. That we have just seen how we have calculated. Now we will see, or we will first consider if I split my data set based upon CGPA. So based upon feature CGPA, we can make a splitting of data set into three different partitions. First partition can have CGPA value high, second partition value can have medium, and third value partition can have CGPA value as low. Now in each of these partitions, there will be some yes samples and there will be some no samples of job offered. Now why always I consider job offered as yes no, because it is an output variable or which is nothing but label of a class. So there are in total two labels, yes and no. So in medium also CGPA we will have two class labels, yes or no, and CGPA low also we will have two different class labels. Now there are only 6 samples with high CGPA. There are 7 samples with medium CGPA and there are 5 samples with low CGPA. If you sum out 6 plus 7 plus 8, it will have value as 18. So this is nothing but total number of samples in original data set. So we have matched this count. Now CGPA is high and output is yes. That many samples are 4. CGPA is high and output value is no, is number of sample is 2. Likewise, CGPA is medium and output is yes is 4. For CGPA medium, output value is no, is number of samples 3. Now we have to calculate total entropy. So I will first calculate entropy of this set, this partition and this partition. How to calculate entropy? So we will calculate P of I, probability of yes. So that is nothing but 4 by 6, that is 4 divided by 6, and here we will have 2 divided by 6. Likewise, we have 4 by 7 because this value is 4 and this total is 7, and here we will have 3 by 7. Here we will have 0 by 5 and we will have 5 by 5. So values are turns out to be, let me clear all these things. Okay. So probability is found, and using probability I can just put for values in this formula minus p of I into log of p of I divided to the base 2. So values achieved is 0.39 and 0.53, 0.46 and 0.52. Summation of these two is nothing but my final entropy. Summation of these two is nothing but entropy of another partition, and summation of these two is nothing but entropy of third partition. Now we have to find out entropy of set after partition, okay, or after split. So as you can see, first entropy is 0.92, second entropy is 0.99, and third entropy is 0. As you can see, this entropy of each partition has to be considered, but along with weight we have to add them. So ultimately I am going to add it, but we have to apply some weights. So what are the weights? Originally we know there were in total 18 sets, 18 samples. So this weight of first partition is 6 out of 18. Here we have 7 samples, that means we will have weight of 7 out of 18, and weight of third partition will be 5 by 18. So this entropy, first entropy is along with weight 6 by 18. This will be 7 by 18 and this will be 5 by 18. Ultimately this component is turns out to be 0, but these two addition value we will have entropy as 0.69. So 0.69 is an entropy if we select CGPA as our splitting attribute. Before partitioning entropy was 0.99 and after partitioning entropy is 0.69. So the difference between these two is nothing but zero point 0.3. So information gain of CGPA attribute is zero point 0.3 that we have to consider. Okay, now we have considered only one attribute. Likewise, we will calculate information gain for communication. Likewise, we will calculate information gain for aptitude. So CGPA used for splitting information gain is zero point 0.3 that we have just calculated. We can also use communication for splitting and calculate its information gain. We can use aptitude as splitting and calculate its information gain, and programming as splitting and calculate its information gain. If I use communication, that is this particular attribute, then we have only two partitions. One partition will be of good and another partition will be of bad. In total, out of 18 samples, there are 9 good samples and 9 bad samples of communication. Within good communication, if selected yes, then there are 7 samples, and within selected no, there are 2 samples. And if within bad communication, selected sample is yes and disselected samples are 8. Likewise, I will calculate their entropy and weighted entropy. In this case, weight will be 9 by 18 and here also 9 by 18 because originally we have in total 18 samples, and 0.576 and zero point 0.5 into 0.50, the summation will turn out to be 0.63. And the difference between 0.99, which is the entropy of complete set, and 0.63 is 0.36. So information gain of second attribute is 0.36. I'll write down over here. Okay, for aptitude, we have two different values, high and low. Out of 18, 11 aptitude high samples are there and 7 aptitude low samples are there. And within this aptitude high, we have count of 8 with yes, selected attributes, and this selected samples are 3. Likewise, for aptitude low, 0 yes attributes or samples are there, and 7 this selected samples are there. Entropy of this partition is 0.85 and entropy of another partition is 0.0. And weighted summation is calculated as 11 by 18 into 0.85 and 7 by 18 into zero point 0. Summation of these two values will be 0.52. Now the difference between original entropy and calculated entropy after partition 0.99 minus 0.52 is nothing but point, I'll write here 0.47 because it is not visible. Moving more forward, the next attribute that we can consider is programming skill. Within programming skill, we can have two different partition. One partition is for good programming skill and another one for bad programming skill. And that value turns out to be 0.95. And the difference between 0.99, that is entropy before partition, is 99 minus entropy after partition, which is 0.95, is turns out to be 0.04. So out of all these values, zero point 0.3, 0.36, 0.47 and 0.04 that we have just calculated, the largest value is 0.47. That means our first branching will be performed based on aptitude because it is having highest information gain. So first level splitting will be based upon aptitude attribute, and because within this particular distribution, as you can see, entropy is 0 when the aptitude is no, low. Okay, that what does this mean? If aptitude is low, we can see that always selection will be return to no. That means if we start with one root node and if we test with aptitude, and if that aptitude is low, we will have always answer that selection is not made. Okay, so this branch is, can we have only one answer, that is no, just because it is having entropy 0. So remember, as soon as you get entropy 0, that means that branch is going to get classifier label. What will be the classifier label? That can be come from the count of that particular attribute. Okay, so I can see that if aptitude is low, entropy is 0, that means always results in same output, that is job offered is no. Now at level 2, we have only one branch, so aptitude can have only two values. One can be low and another can be high. So we have to work with high only because no is our classifier or leaf branch. Now how to make second level tree. So we will consider only those samples which is having high aptitude. That means from 18 samples, out of 18 samples, there were only 11 samples which are having high aptitude. So we are going to consider only those many 11 records for which aptitude value is high. So for all this, as you can see, CGPA communication and programming skill is kept, but there is no as aptitude. Why? Because these all attributes or samples are having attribute value as high. Now again, before exploration of this particular value, we have an entropy of this set that we need to calculate. So let us calculate entropy of this set. So level 2 starting, we have in total 11 samples, out of which we have 8 yes samples and 3 no samples. So this is my entropy of set before splitting of second level partitioning. Okay, now let us start with splitting at CGPA. For CGPA, we have three different values, high, medium and low. So we will make three different partitions, CGPA high, CGPA medium and CGPA low. Within high, we have total 4 samples out of 11. We have 5 samples of medium type out of 11 and total 2 samples out of 11 of type CGPA low. Now within CGPA low, how many yes samples are there? 4. CGPA low, high with no values is 0. Likewise, we will make a count of each. We will calculate Pi and P of I into log of P of I. We have calculated their entropy 0.00, 0.72 and 0.00. Now we will make weighted summation. So weighted summation will be 0 into 4 by 11, 5 by 11 into 0.72 and 2 by 11 into zero point 0. So that value is nothing but 0.33. So this 0.33 is total entropy if we split data based upon CGPA, and the difference between these two is nothing but an information gain, which is 0.52. Likewise, I will select another attribute, that is communication. Within communication, there are only two values. So only two partitions will be made. Out of 11, we have total 7 good partitions, total 4 samples of bad communication. And likewise, I will see how many yes are there within good and no's are there in good, how many yes are there in communication bad and no's are there in communication bad. Likewise, we will calculate their entropy. The weight will be calculated as 7 by 11 and 4 by 11 for each of them respectively, and multiplying entropy with this weight and adding their sum is 0.30. Now the difference between before entropy and after entropy is nothing but 0.85 divided by 0.30, which is turns out to be 0.55. If it is not visible, I will rewrite for you. And likewise, if I calculate based upon programming skill, I get information gain as 0.05. Now let me rewrite all these information gain. If we are splitting with the help of CGPA, IG is 0.52, 0.55 when it is communication, and 0.05 the programming skill. As I said earlier, higher the information gain, better the branching node. So here the highest information gain is for communication, so that will be used for second level splitting. So second level split is based upon communication. So this is the communication distribution. Within this communication, you can see entropy is zero when communication is good. And this good communication will always result in job offered yes. So we can say that at some level, when we are dividing based upon communication and it has two values, communication is good and communication is bad, good communication will always leads to job offer selection, yes. And this bad communication is further needed to be splitted based upon some criteria. So at level 3 only, we will branch at communication is equal to bad. Okay, so at we will start with level 3. First, look at this A diagram. This is level 3. This is the mistake that is given. This is level 3 starting set with aptitude high and communication bad. In total, there are 4 samples, and out of those 4 samples, one is yes sample and 3 is no sample. So its entropy is 0.81. So for this particular set, entropy is 0.81. Now we will first select partition upon CGPA and calculate information gain. Later on we will select programming skill and calculate its information gain. So method is same. If I select CGPA, we will have three different partition, we will have three different entropy and three different weights. That is 1 by 4. This is also 1 by 4 and this will be 2 by 4. With the same method, weighted method, we will calculate total entropy, and the difference between original before partition entropy and after partitional entropy is my information gain, which is 0.81 in this case. If you are not able to visit this part, I rewrite it. And if I select programming skills, we have only two values, good and bad. So we will have only two partitions. In each of these partitions, we have two different samples, and we will calculate entropy and information gain respectively. So as you can see, if we split at third level with CGPA, information gain is 0.81, otherwise information for programming is 0.31. Higher the information gain gives the better partitioning. So CGPA will be our next node which can be used for partitioning. But before we make CGPA as our partition, it can have three different branches. As we know, CGPA can be high, it can be low, or it can be medium. If CGPA is high, always it is classifying as yes for job offered. Okay, so if CGPA is high, job will be offered. Yes, output will be surely there. If CGPA is medium, output is always no. That means job offered will be output always no. And if CGPA is low, again entropy is zero. So as you can see, always value is no. So CGPA is low, always output value will be no. So you can see at third level of CGPA, if CGPA is high, entropy is zero and always results into yes output. At CGPA medium, entropy is again zero and output will always lead to no. And when CGPA is low, entropy again zero and always results into job offered is no. So At this stage, we have all three branches of CGPA covered, which is showing our final class label. So there is no branch that is left in this decision tree, which can be later on exploited. So I will make it as start complete set. We have an aptitude. Aptitude can be low or aptitude can be high. If it is low, always your class label will be no, that job will not be offered. If aptitude is high, we have to test on communication skills. Okay, now this communication skills can be of two type. It can be of good type or it can be of bad type. If communication is good, always output will be yes, that is your condition or class label. If communication is bad, then we have to check CGPA. As you can see, CGPA can have three different values, but for medium and low, output will always no. So this is my class label, and for CGPA high, output will be always yes. So this is my complete decision tree for a given data set of 80. So that is all for today. In today's video, we have seen how to build a decision tree and how to calculate entropy of decision tree for information gain used for branching. Thank you everyone for watching this video. This is Munira Topia signing out.